Welcome guys, welcome to my video channel. So this video, let's talk about the famous inequality in elementary school, high school. So arithmetic mean greater equal to geometric mean greater than harmonic mean. So let's notation is set up to be x1 up to xn greater than 0. So we see that the arithmetic mean defined to be x1 plus x2 up to xn divided by n, and the geometric mean means that you product x1, x2 up to xn and take a nth root. And harmonic means that n divided by 1 over x1, 1 over x2 up to 1 over xn. Okay, so before I start, hope you guys, let me just quickly introduce my channel. Otherwise, yeah, this is very important. So yeah, I'm Eric. If you're the first time come to my channel is about teaching mathematics from high school to graduate school. And if you're interested in abstract math in college, then you can go to check out my list. Instead, if you want to see some brain teaser, and sometimes I will introduce some interesting math questions. And I will upload funny math questions in 1 to 3 days, and I will solve them one by one and share with you guys. Click the notification button and subscribe button so that you will not miss my latest video. Leave the comment below and what you'd like me to do in the future, and what you learn, and click the like button. Okay, so my plan for this video is that I will prove this inequality by assuming arithmetic mean greater or equal to geometric mean, and I will prove that if you assume this, then you can prove this. Okay, and finally I will use 2 ways to prove arithmetic mean greater than geometric mean. So basically, in this video, we will discuss the basic feature of this inequality and give you guys an idea and all the detailed proof. Okay, and one of the proof I want to use is calculus. One of the proof without calculus. Okay, without calculus is much complicated. Okay, so let's assume that am greater than gm. So and we want to prove that implies that gn greater or equal to hm. Okay, this is very famous, very easy, right? So this is the x1 up to xn. Okay, so let's say I change x1 to be 1 over x1. Okay, and x2 change it to 1 over x2. So am greater than gm will give us this. Right? Okay, so you can flip. So you get this. Right, so this is exactly the gm greater or equal to hm. Okay, so that means from this equality that actually only this part is important and this part is trivial from the first part. Okay, so the next is that we prove the arithmetic mean greater than geometric mean. Okay, so let's go here. So there are various ways, right? But what I want to prove at the beginning is that n equals to 2k. So when you have only 2, let's say you can take a 1 over 1 square root of x1 minus square root of x2, and take a square. Then it's basically x1 plus x2 minus 2 square roots of x1 x2, which is greater than 0, right? Because the left hand side is greater than 0, greater or equal to 0. So you get x1 x2 divided by 2 greater or equal to square root of x1 x2. Right, so this is a trivial, right? Okay, so since now we can do the so in order to prove it, what we need to use is the strange idea in the mathematical induction. So let me just write down the idea. So I will prove that. So we already proved 2 is correct. Then we prove 4 is correct. Then we prove 8 is correct. And we prove 16 is correct. So basically, we want to prove that 2 to the k will be correct. So this is the step 1. Okay, so let's see why it is. And this is obviously, right? So suppose n equals to 2k minus 1 is correct. So this is suppose. And the k equals to 2 we already checked, right? So let's see n equals to 2k. So let's say we want to prove that n equals to 2k is correct. Suppose we know this, right? So let's say you have you have x1, x2, x3, x4, right? Up to x2 to the k minus 1 and x2 to the k. So let's say we sum all of it. But by n equals to 2k minus 1 is correct. So I can group them. So I can group the first two, these two. So and I get 2k minus 1 number. So by this one, then I can write as this. Correct? And once I read this, I can use the, since I say any 2k minus 1 number is correct. So this is the same as 1 over, right, sorry, 2k minus 1, 2k minus 1, and x1 plus x2 divided by 2 times x3 plus x4 divided by 2 up to x2k minus 1 plus x2k divided by 2. And this term, right, we can use the n equals to 2 cases. So this is square root of greater than square root of x1, x2, square root of x3, x4, square root of x2k minus 1, 2k. 1 over 2k plus minus 1, right? So, but so I can combine all of these since they are all in the square root. So I get x1, x2 up to x2k minus 1, x2k, 1 over 2k, because there is a square root. Okay, so now we prove that 2 is correct, 4 is correct, 8 is correct, 16 is correct, right? So let's go to the step 2. Okay, so the step 2, we need to show general n is correct. So I can write n equals to 2. I can write m. Okay, so since now n is not the same as 2k, right? We already say 2 to the power k is correct. So we can say that let's say there exists okay, so there exists a k such that n plus m will give you 2 to the k, right? So basically we just build some other numbers to make that 2 to the k equal to n plus m. Okay, so now suppose you have x1, x2 up to xm. Xn, then I need to give you other m numbers such that this is correct. So I can define other m number called alpha. They are all called alpha, and the total they have 2 to the k minus m. Okay, and alpha is defined to be just their ratio, just their mean. So basically, I build another m number to make sure that they are 2 to the k. Okay, and then I can use the mathematical induct, and I can use the 2 to the k arithmetic mean geometric mean inequality. So I get x1 up to xn divided by, let me just write down. So we get x1 plus x2 up to xn plus m alpha, right? So m alpha divided by total, we get 2 to the k will greater or equal to x1 up to xn alpha. We have m alpha, right? So m and 1 over 2 to the k. Okay, and notice that m is the same as so this let's say, so total, sorry, this is 2 to the k minus n, and there are m of them, right? So m is the same as 2 to the k minus n. Okay, so let's see what do we get from here. So we get x1 xn plus 2 to the k minus n, x1, remember xn divided by, so this is alpha, right? And 2 to the k. So your left hand side, actually, if you see correctly, will just be this. So if you combine these two, right? If you combine these two, then you actually get the let me see. So you get yeah, you got this. Okay. Okay, so let me just write the detail. So you get the n, right? And n x1 xn plus 2 to the k minus n x1, right? So you see this part, these two part cancel. So you get the 2 to the k times this and divided by 2 to the k. So you get the same thing, right? Since you fit the same. Okay. So now we get the x1 up to xn divided by n greater or equal to x1 xn alpha m 1 over 2k. And we hope to show this is the same as x1 up to xn 1 over n, right? So the rest is just to try. Whether one can keep going. Okay, so this, let me just write down. You get x1 up to xn 1 over 2k alpha m divided by 2k, and alpha is the same as alpha is this, right? I don't know whether you guys see the trick. So this is alpha. So you get the alpha greater or equal to x1 xn 1 over 2k alpha m divided by 2k. So alpha 1 minus m divided by 2k greater or equal to x1 xn 1 over 2k. 1 minus m divided by 2k, this guy is n divided by 2k. N divided by 2k. Right? So total times 2k power. You get alpha n greater or equal to x1 up to xn. And divided by n, so you get alpha x1 xn. So you take a n square roots, so you get this. So this is left hand side is x1 up to xn. Okay, so finish the proof. Okay, very difficult. Okay, so that means yeah. So I define this to be alpha just for fun, just for easy calculation. So now we get a proof. Okay. So finally, let's talk about the calculus proof. Okay, so now let's go to the second part. So second part is that we need to prove the theorem. Suppose we have a number, right, and let's divide average mean, arithmetic mean called alpha, and we need to prove it. Okay, so this is our goal to prove the arithmetic mean and the geometric mean identity. Inequality by calculus. Okay, so it's not directly by calculus, but I would first establish that I define f of t. Maybe f of x is better. Defined to be exponential x minus 1 minus x. Okay, so let's see what is x zeros. So if x is 0, so if x is 0, then we get the 1 over e, right? And then let's see the derivative. Okay, so the derivative is this. So let's see f prime of 1 is 0, right? So an exponential is increasing, right? So that means if x greater than 1 is greater than 1. So that means when x greater than 1, then this function will start to increase. When x equals to 1, right, you get the 0. So that means this function looks like this, right? So final results that we can say that f of x greater or equal to 0 when x greater or equal to 0. Okay. So we only need this red part. Okay, so let's finish. Okay, so now we already have these results. We have exponential x minus 1 greater or equal to x when x greater or equal to 0. Actually, this can be shown that for all x, right? Because this will be negative when x is less than 0. Okay, so let's say I define I let x to be the first x to be x1 divided by alpha. So we have x1 divided by alpha greater or equal to minus 1 greater or equal to x1 divided by alpha. And then we have exponential x2 divided by alpha minus 1 greater or equal to x2 divided by alpha, and keep going. We have exponential xn divided by alpha greater or equal to xn divided by alpha minus 1. Okay, and then we times all it, we get exponential x1 divided by alpha plus x2 divided by alpha up to xn divided by alpha minus n, right? Because there are n of them greater or equal to x1 up to xn divided by alpha n. Okay, but remember that alpha is what? Is this. So this guy will be exponential x1 up to xn divided by alpha minus n greater or equal to x1 alpha times xn alpha n. So this guy, right? This guy is 0, right? Because divided alpha will become n. So this guy will be n. So we have alpha n greater or equal to x1 up to xn. Okay, so this is the second proof of arithmetic mean and geometric mean inequality. Oh, okay. So be sure to subscribe to my channel. See you guys in the next video.